Okay, so 8.1 is apply exponent properties involving products So just to kind of start out, if you had something like this, a cubed times a squared, okay, then what we have is the a cubed is a times a times a, and then the a squared is a times a. So then if I multiply all these together, I have, okay, 5 a's, which gives me a to the 5th. Okay, so that just goes to show us that when you're multiplying things that have the same base, you add the exponents together. So this was a to the 30 plus 2. Okay, and that is on that poster over there on the wall, that green poster. The second point down is this particular rule. Okay, so we have a product of powers property. So let A be a real number. And let M and N be positive integers. Then in words, we have to multiply powers, having the same base, add the exponents, okay, algebraically, that means that a to the m times a to the n is equal to a to the m plus n. And then an example of that, 5 to the 6 times 5 to the 3 is equal to 5 to the 6 plus 3, which is equal to 5 to the 9th.
Can you solve that?
Since you don't have a calculator, I would just let you leave it like that. Because I don't expect you to know what 5 to the 9th is off the top of your head. Pretty much anything to like the second or third power, I would expect you to multiply out. Now, if I told you to do like 18 to the third power, I'm not expecting you to do that. But if I said like 6 to the third, I mean, you should be able to do 6 times 6 is 36 and then multiply by another 6. You may need to write it out by hand, but I mean, that shouldn't be anything too crazy.
What if it was like 5, 6 times 4, 3? Equals,
Like 5 to the 6 times 4 to the third. You could not combine them like that because they don't have the same base. So these numbers here have to be the same in order to be able to combine them like we did here. All right, so the next one is a power of a power property. So we let A be a real number. And let M and N be positive integers. In words, to find a power of a power, multiply the exponents. So over on that poster over there, that would be the third option. Okay, that third bullet point. So for algebra, what does this look like? We've got a to the m raised to the n is equal to a to the m times n. And then an example of this one, if we had something like 3 to the 4th all squared, it would be equal to 3 to the 4 times 2, which is equal to 3 to the 8th. And then we've got one more. We've got the power of a product property. So this one, let A and B be real numbers. And let m and n be a positive integer. Then in words, we have to find a power of a product. Find the power of each factor and multiply. So in algebra, this would be something like a times b raised to the m is equal to a to the m times b to the m. And what this would actually look like as an example, we would have something like 23 times 17 all raised to the m. This would be, or sorry, not to the m, to the 5. This would be something like 23 to the 5th times 17 to the 5th. Okay, and then you would just have to multiply that out. But obviously, I'm not expecting you to be able to do that, so you could just leave your answer there if that was the actual problem that you were given. And technically up here, I wasn't paying attention, but I didn't really need this n because there was no n in that problem. So I just needed m. So your book has some guided practice problems throughout the notes and example portion. So I think we'll go over those today, and then maybe a few, I may assign a few homework problems for you guys just to try. So the first one, this one's on page, these are on page 489, but they go through page 491. So we have 3 squared times 3 to the 7th. Okay, so I've got the first option that we talked about, okay, the product of powers property. Okay, I'm multiplying two things that have the same base on them. So that means I need to write it all as 1, and to do that, I'm going to add these exponents together. So that's going to give me 3 to the 2 plus 7, which is equal to 3 to the 9th. Okay, as you go, I don't care so much if you write this step, okay, this 3 to the 2 plus 7. I don't care if you, like I said, if you show that. You're more than welcome to go straight from the beginning to the 3 to the 9th if you just want to do this step in your head. But I will show it as we go just so that when you refer back, you can see kind of what we did in different places. All right, the next one is 5 times 5 to the 9th. Okay. So now, this is something you may not have seen, or it may have been a while. What exponent is on this first 5?
1.
Okay, a 1 is there. So just don't forget that when you go through to do these, okay?
We write 1?
You don't have to write it. I just am, again, just so when you look back, you can see, you know.
But it wouldn't be wrong if we wrote 1.
No, it's completely fine to put it, but it's not it's not a requirement, I guess what I'm trying to say. So then I can do this as 5 to the 1 plus 9. Okay, sometimes it is nice to go ahead and put it here because some people will forget to add that in. So it does have its benefits to writing it, but it's not wrong if you don't.
Is there like a 0? I'm guessing not.
Well, so you could have something like this, but if that's true, this is equal to 1. Anything raised to the power of 0 is equal to 1. So I could give you 2032 raised to the 0, and that's also equal to 1. So you probably won't really see that with these particular problems that we're doing in this section, but that is something you could see for sure. So 5 to the 1 plus 9, so 5 to the 10th. All right, this next one, same thing. It's just going to be written a little differently. So I've got -7 squared times -7. Okay, these ones they're writing in parentheses, and most of that is because they have that negative sign. Okay, and so when you are, well, let me just make this little comment over here to the left. This is not equal to that. Okay? If it's written like this, then my answer would be -49. Okay? If it's written like this square goes to the negative and to the 7. A negative times a negative is positive. 7 squared, 7 times 7 is 49. And those are not equal to each other. Okay, so part of the reason that they write it this way is so you know that the power that's on it goes with
Why is
the exponent.
Not negative?
Because I'm essentially what I have here is -1 times 7 squared. And so then -1 times -1, which I'm going to just put them in parentheses just because that's going to get confusing, times 7 times 7. Negative times negative is positive. And then I'm just left with that.
So that's always positive.
If the negative is inside with an even power, so like 2, 4, 6, 8, something like that, then it's going to become positive. But if it was that, okay, well here, let me use an easier number that, in this case, again, this cube is only touching the 2, so the negative comes down. 2 times 2 is 4, times 2 is 8. So that's negative 8. An odd power, okay, 1, 3, 5, 7, 9, okay, those things do not change the negative sign because it's a negative times a negative, which becomes positive, times another negative makes it stay negative. So then that's negative, and then 2 times 2 times 2 is still 8. So in this case, these are equal. So if it's an odd power, they're going to be equal. But if it's an even power, they're not going to be. If you have these two different scenarios here.
Do you have a negative exponent?
Yes.
With this 7?
You can have a negative exponent, but I don't think that comes up in this section at all. It probably comes up next section. It looks like 2 sections from now we officially do it. So we'll briefly talk about it in the next section, but 8.3 is where it really hits. So. All right, so this is negative 7 k squared and negative 7 to the first. Okay, so I can write that in if I want to. So then this gives me negative 7, and I'm going to keep the parentheses with it. Okay, raised to the 2 plus 1, which then is negative 7 to the third. Okay, and it's fine to leave it like that. It's, again, it is equal to negative 7 cubed like that because of what we talked about with the negative times negative times negative. Still keeping it negative. Okay, so either of these answers would be acceptable there in that scenario. Okay, so obviously these ones have all been with numbers. So let's look at one that's got variables in it instead. So like x squared times x to the 6th times x. Okay, again, notice this time we even have 3 things here that have exponents on them. Okay, so I've got this final x is still an x to the 1st. So I'm going to add the exponents. So that gives me x to the 2 plus 6 plus 1, which is x to the 9th for that one. So that's all bullet point number 2 over there, okay? As long as that poster is up on the wall, it's fair game to use. So if it's up during the quiz and you have forgotten your rules of exponents, feel free to look over there, okay? I'm not inclined to take that poster down. It's not cheating if I'm telling you you can use it, so it's there if you forget. It can maybe help you a little bit, okay? So the next set of guided practice problems on page 490, okay, deal with the third bullet point over there, okay, the second, the one that I wrote in purple here. It's going to deal with that, so it's going to be something like a to the m all raised to the n, okay, meaning we're going to be multiplying our exponents. So with this one, we've got 4 squared raised to the 7th. Okay, so again, with something like this, this means that I am going to be multiplying my exponents. So this is going to be 4 to the 2 times 7, which is 4 to the 14th for this one. Number 6, negative 2 raised to the 4th, all raised to the 5th. Okay, I've got the brackets and the parentheses just because I want to keep that negative 2 together with its negative sign, and then that piece is raised to the 4th, and then I'm raising the whole thing to the 5th. So again, I have a power raised to a power. So I multiply my exponents. So that's going to give me -2 raised to the 4 times 5, which is -2 raised to the 20th. Okay, and because 20 is an even number, I could also, and again, I'll take it either way, but I could also write this as 2 to the 20th, okay, because the negative with this being an even power will go away. Okay, so either of these answers would be acceptable for this particular one. Okay. All right, so I want y'all to tell me what we have for the next one. N cubed raised to the 6th. Yes.
Okay.
All right, what'd you get?
I got 18 over in, like, wait, how do you say
N raised to the 18th.
that?
Okay, so n to the 3 times 6, which is n to the 18th. All right, the next one, m plus 1 raised to the 5th, and then the whole thing raised to the 4th. Okay. Now, I'm going to pause right here, and I'm going to tell you that a common mistake that I see, okay, I'm going to write it, and then I'm going to get rid of it, okay? Don't actually write what I'm about to write, but I want you to see what a common mistake is. This is not equal to m to the 5th plus 1 to the 5th, all raised to the 4th. Okay? That is not a true statement. This power means that we have m plus 1 times m plus 1 times m plus 1 times m plus 1 times m plus 1. Okay, that's what that means. Not m to the 5th plus 1 to the 5th. Okay, if you actually were to multiply all that out, it would not give you the same thing. So again, I'm just warning you, don't do it. I'm getting rid of it because it's a mistake that is commonly made, and I just don't want you guys to make it. Okay, so we're going to treat m plus 1 just like we treated n in the last one. Okay, we're going to leave it all as one piece. So m plus 1 raised to the 5 times 4, which is m plus 1 raised to the 20th. All right, so then the next ones, okay, are the type, okay, that we mentioned here in green, okay, where you have two things being multiplied all raised to a power, okay, which just allows us to split them and raise each piece to the power, is all that's happening here. So with number 9, we've got 42 times 12 raised to the 2. Okay, so in this case, because this is multiplication, I am going to put this 2 on both pieces. So my answer is just going to be 42 squared plus 12 squared. Or sorry, not plus, times 12 squared. Okay? Because it's multiplication, I can do that. Okay, in the previous one, I couldn't do it because it was addition. So when it's addition, I cannot just throw it on each piece, but when it's multiplication, I can. Okay?
So that's the answer.
Yep. So you would just leave it like that. Now, if you had a calculator or whatever, you were so inclined, you could multiply it all the way out if you really wanted to. But I'm completely okay with you leaving it like that. 12 squared, you should probably know what that is. 12 times 12 is what?
130. 144.
Close. Yeah, 144. Okay, 42 squared, not expecting you to know that. So, again, like, you can leave it like that, and that's completely fine. But all right, if you have something like negative 3n all raised to the 2, okay? This now has, instead of 2 pieces like we had in number 9, we have 3 pieces that are getting something done to it, okay? Or we can treat the negative 3 as one piece and the n as its own piece, okay? I kind of like leaving the negative with the 3. One, it just saves an extra step of writing, and 2, it doesn't really make sense to just write the negative sign by itself. So I'm going to break this up into negative 3 and to n, okay? And both pieces are getting squared, so I just need to write the squared, or the 2 at the top of both pieces, okay? And then, now, negative 3 squared is something that you should be able to do, okay? The negatives, because it's raised to an even power, what happens to it? Negative times negative is what? Positive, okay, so that's going away. And then 3 times 3 is 9, so this is going to be 9n squared. Okay, and that would be my final answer. For this one, I would want you to go all the way because, again, negative 3 squared, you should be able to do that. Okay? All right, with one like 11, I've got 9m cubed times n all raised to the 4th. So what do we think that means?
There's a lot of ways you can do it.
Okay.
Well, it's times n, right?
What?
Is it 9n?
9m cubed times n. So this is all, we have 3 individual pieces here.
You would do 9m, 9m, and then with 3 times 4 over that. The n would just 4.
Okay, and don't forget, and maybe this was what you were trying to say, but don't forget that the 9 also gets a 4 on it as well. Okay, it goes to both pieces, and then you were right. Okay, this could have been written as 9 to the 4th, and then m to the 3 raised to the 4th, and then n to the 4th. Okay, but you went ahead and just told me that we're multiplying, which is fine. Okay, this is just another way to have written it to start with. Okay, alternate starting point. Okay, so then this gives me 9 to the 4th. I don't expect you to know that, so just do 9 to the 4th. And then m to the 3 times 4 is 12, and then n to the 4th. Okay, and as a general rule, we always want numbers as far left as possible, and then we go letters in alphabetical order. So, not that you couldn't write it a different way, but we try to put things in alphabetical order with numbers at the very front if possible.
So, is there like a way to space those? Or is that like the whole answer?
That's the answer. So that right there is your answer.
I feel like
Like, if you are like, I don't like how that looks, I want to rewrite it, like, just so that you can clearly tell
Okay, yeah.
what everything is, like, that's fine.
That's what I'll do.
But the way that I have it written in the box is the way that you'll typically see it written.
I feel like I write it too close together.
Yeah, some people do, and it does make it a little bit hard for me to grade. So if you do have it in parentheses, then I can at least tell, you know, it makes it a little easier for me to see it too, so that's fine. All right, so one more of these ones. Getting a little harder. 5 times, and then in parentheses, 5x squared, all raised to the 4th. Okay? So we're going to take this one piece at a time. Okay, at the moment, this 5 is all by its lonesome. Okay, nothing happening to it, so I'm just going to copy it over. Now, in parentheses, I've got 5x squared all to the 4th. So what is happening here? Or how do I need to rewrite this part?
Are you just gonna put 5x with like 2 times 4?
No, like this, alright? So the 5, it's 5 and then 4.
Okay, so 5 to the 4th, and then he said the
Oh.
x to the 2 times 4, okay? The
Yeah.
common thing that I do see a lot, okay, that it's happened a couple times in here, you know, as I've asked questions, is that we forget to put the 4 on the number as well, okay? We forget to raise the number to the power. I do remember that happening a decent amount previously when I've taught this, so just make sure you remember, and if you need to do like the little distributing thing to show you that, you know, to help you not forget to do that, you can. Okay, so now there's a couple different things going on. I now have 2 base 5s. Okay, this first 5, remember, has the power of 1 on it. And then I've got this x to the 2 times 4. So the x to the 2 times 4 is going to give me x to the 8. Okay, what about this 5 to the 1st times 5 to the 4th?
Multiply. I'm guessing. Probably.
Multiplying the numbers, what am I doing to the exponents? Look at point 2 over there.
Add or subtract.
So you're just adding them?
Okay, so I'm going to add them together. So 5 to the 1 plus 4, okay, which gives me 5 to the 5th times x to the 8th. Oops, sorry. Let me slide it up some.
And that's the answer.
Yep, and that would be it. Okay, the book, if you go to check your answers in the back, they will most likely multiply out 5 times 5 times 5 times 5 times 5. I don't care if you do that. Okay, again, if it's like 3 squared, 3 cubed, you know, 4 squared, something like that, I expect you to multiply it. But if you're getting out here to like 5 to the 5th, I don't expect you to know that or to sit and take time to do that. That's kind of a waste of time. If I actually wanted you to do it, I'd tell you to type it in on a calculator. So, all right, I'm going to give you the last like 10-15 minutes, okay, to work on a few problems. We'll do some more examples, you know, tomorrow, because I know obviously a couple people are out, so I'll probably need to go over a few more anyways. But in the short term, okay, these are not due tomorrow. They will be due with all the rest of it, but with the time left over, it would be good to just kind of get a jump start on looking at it and just make sure you know where we are. 3 through 17 odd. Okay, that sounds like a lot, but again, you can see these problems go relatively quickly. It's on page 492. Okay, so I will add to that tomorrow, but for now, those are the problems that you can work on. And so there won't be a tab yet just because it'll all be due together at the end of the section.